The objective of this project is to interface Arduino with LCD display, and the components required for this project is Arduino, UNO board, LCD screen, pin headers to solder to the LCD pins, a 10 kilo ohms potentiometer or presets, a 220 ohms resistor, hookup wires or connecting wires, and breadboard. So now let's see the circuit diagram for this project. So this is the circuit diagram, and this is the schematic diagram. So now let's see about the code. So this is the code while interfacing Arduino with LCD display. First of all, we need to write this library in which we need when we do with the LCD display, that is liquidcrystal.h, and then we initialize the library with the numbers of the interface pins, that is which pin we connect our LCD to the Arduino. So the pins that we use to connect to the Arduino is the pin number 12, number 11, number 5, number 4, number 3, and number 2. And in the void setup, we set up the LCD number of columns and rows. That is, LCD begins 16:2, which means it has 16 columns and 2 rows. And in the void loop function, first we write a delay for 500 milliseconds, and then we set our cursor. If we set like 0, 0, it means that our alphabet will display in the column 0 and row 0 in the LCD display. And the second one, that is we set our cursor to 0, 1. It means that the alphabet E, it will display in the column 0, and then the row is row 1. So that is for the program. Let me explain about this circuit diagram. The variable resistor R3, which is of 10 kilo ohms, its function is to control the contrast of LCD display. And in LCD display, you see the pin number 15 and pin number 16, that is LED plus and LED minus. Its function is for the backlight of LCD display. And in this figure, you will see a resistor R4 is connected to LED plus to limit the current while applying a 5 volt to LED plus. And in a pin number 4 of LCD, you will see RS, which means register select. This pin controls the LCD memory you are writing data to. And pin number 5 RW is the pin that selects reading mode or writing mode. And pin number 6 is enable, and its function is to enable writing to the register. And DB0 to DB7 are the 8 data pins. And in this project, we use only DB4 and DB7. So this is our LCD display. The name of this LCD display, it often written like 16:2, which means that 16 is the number of columns and 2 is the number of rows. So if you see this small square, like this is the first row, and this is the second row, and the column, this is the first column, second column. If we count the column from here up to here, we will find that it is 16, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it has 16 columns and 2 rows. But in the program, we cannot write like this one is first row or 1. In the program, we have to write that this one is 0, this one is 0 rows, and this one is 1 rows. Instead of 1, we will write 0, and instead of this one 2 rows, we will write 1, and this is the column. Like if we want to put alphabets here, like we want to put the alphabets W in this square, so we have to set our cursor. For this one is the column is 0 and the row also is 0. But if we want to put like alphabets here in this small square, so it means that the column is 0 but the row is 1, because this is the row 1, this is the row 0 and this is the row 1. So it means that this one is 0, 1, and this one is 0 up to 15. So the components required in this project is, the first one is LCD display, next Arduino UNO board, the potentiometer which is of 10K, and we can use in this project, we will use preset instead of potentiometer, and this resistor which its value is 230 ohms, and the last one is we have to use this connecting wires which is the jumper. Okay, so today I will show you how to do the connection with respect to the circuit diagram. So first of all, we will insert this LCD display in this breadboard. Okay. So we will see from circuit diagram that from the BSS of the LCD display, this is BSS, this is BSS, and this is the LCD LED minus, this is LED plus, this is BSS. So we'll start from here, from this BSS. So from this BSS, it will go to the ground. So I will make this upper part of this breadboard as ground, and this lower part I will make a positive 5 volt. So I will connect this one also. So first of all, we will connect from this BSS of this LCD to the ground. So this is the ground. So from BSS to the ground. This to the ground. And then from BDD, it will go to a 5 volt. So this is BDD. And then from B0 it will go to the variable terminal of preset. So from this B0 we will go to this variable terminal of this preset. And then after B0, RS. From this RS, which means this pin, from this RS, it will go to the number 12 of Arduino. So from this RS, we will go to the, this is the number 12 of Arduino. This is 8, this is 8, 9, 10, 11, 12. Okay. And then RS, and then RW. RW will go to the ground. So this is my RS, this is my RW. So RW will go to the ground. This RW will go to the ground. W finish, and then from E, this is E will go to the pin number 11 of Arduino. So this E will go to pin number 11 of Arduino. This is 11. And then from the pin number we have to left DB0 is no connection, DB1, DB2 also no connection, DB3. So we will start from DB4. So 1, 2, 3, 4. So we will start from DB4. Okay, DB4. From DB4 of LCD, therefore we will go to the pin number 5 of Arduino. 7, 6, 5, and then DV5. From DV5 we'll go to pin number 4 of Arduino, and then from DB6 we'll go to pin number 3 of Arduino, and then DB7 we will go to pin number 2 of Arduino. And from LED positive it will go to the resistor of 220 ohms, and then it will go to a 5 watt. So from this LED positive inside this resistor, and then I will put to 5 watt. Okay. And then from the negative LED it will go to the ground. Here the ground and the 5 watt. So first we will connect the ground on the ground, and now we will connect the 5 watt. So this is the 5 watt. And now we will insert our Arduino in this PC. And then we need to connect from this one terminal of this preset, we need to connect to the ground. And it's another terminal to the 5 watt. So that's all about the connection. Now we will upload our program. So now let's open our Arduino IDE software. So click on it. Okay, it's now loading. Okay, first let's delete this program. So now we will go to our program for the LCD display. Okay, here it is. So we will copy all this code and we will paste in our Arduino software. Copy it, and then we will paste it here. Paste it. Okay. So now we'll compile it. And then we will upload it. Okay, it is done uploading. So now we will go to our breadboard to check that this alphabet is displayed or not in our LCD display. So you see here, after uploading the program, we see that our alphabet H is standing in a column 0 and row 0, and our E is standing in our column 2 and row 0. So now let's go again to our Arduino IDE software, and let's change the alphabet, and let's change its cursor position also. So now we will change the position of our alphabet. So for this set cursor, now we will change to the column 2, 3, and the row we will change, put again to 0. And for this alphabet, instead of H, I will write W. capital W I will write. Okay, let's say in the cursor position of this one I will write, for the column I will write 6, and for the row I will write 1, and for the alphabet from E I will change to T, capital T. Okay, so now let's compile, let's upload directly. Okay, so let's click again on upload. Okay, it is done uploading. Okay, let's go back to our billboard and check in our display, it's coming on now. Okay, so now we see that our alphabet W is standing in a row number 0 and column is number 4, and our T alphabet is standing in the row number 1 and column is 1 2 3 4 5 6. So we see that we can arrange or we can assign our alphabet by writing in the program in that set cursor with respect to their position. So we can put anywhere in this row or column in the LCD display.